Hi, this is Dr. S. Welcome to the second video in my series for Year 13 Rates of Reaction for A-Level Chemistry. In this video we'll look at the rate equation, which is where we're going to use the orders of reaction we found in the last video. So any reaction will have a rate equation, and the rate equation looks like this. Rate equals K, concentration of A to the power A, concentration of B to the power B. So this is a generic rate equation for a reaction that has two reagents A and B. So rate is obvious, that's the rate in moles per decimeter cube per second. K is known as the rate constant, and that is a value that is constant for any particular reaction at any particular temperature. My next video will be about the rate constant, so we'll come back to that then. A and B are the two reagents, and the small a and b are the orders of reaction with respect to each of those reagents. So this is reagent A raised to the power either 0, 1 or 2, depending on whether it's a 0 first or second order reagent, times by the concentration of B raised to the power B, which again is either 0, 1 or 2. So let's look at a couple of examples of how we'd develop these rate equations. Let's say I had a reaction in which I had, let's say C plus D makes E plus F. And my C is a first order reagent and my D is a second. As we found in the previous video, that means that's a third order reaction overall. But let's look at how that's put into a rate equation. They always start off rate equals K, and then I'd have my concentration of C, which is this, raised to the power 1. But of course, raising to the power 1 is just itself, so I don't have to put a power there. I'll just leave it as that is. Multiplied by concentration of D. This is second order, so it's raised to the power 2. So that would be the rate equation for this overall equation. If I do another example that includes 3 different reagents, then we'll see how that one works. So let's say I had this example. H plus I plus J makes K plus L. These are just nonsense chemicals, but 3 reagents. Let's say this was first order, this was 0, and this was second. Again, we'd look at how to put the rate equation together for this. It would be rate equals K. H, so the concentration of H is to the first order, so that's raised to the power 1, so we just leave it as it is. Now I is a 0 order reagent, so my concentration of I would be raised to the power 0. Now anything raised to the power 0 is just 1. So if something's a 0 order, it doesn't actually appear in the rate equation. We don't have to write it. Because if I wrote I to the power 0, actually what I'm doing is I'm just multiplying everything by 1. So I can skip the I, go to my J, that's second order, so I'll raise that to the power 2. Yeah? Right, so let's look at some examples with actual chemicals. So how about this one here where I have you might have seen this at Year 12 Organic. And let's say that that is first order and that is first order. My rate equation would be rate equals K, concentration of bromomethane, and it's first order, so I don't have to raise it to a power necessarily, that is raised to the power 1, multiplied by hydroxide ions, and again that's to the power 1, so I don't have to write anything. That would be my rate equation. So what I'm going to do is I'm going to put a couple of examples on the next page, and I'd like you to pause the video and have a go at them. So let's say we have a reaction in which we have NO2 reacting with O2. Now the products are actually irrelevant, so I'm not going to put them on. But let's say that is second order and that's first order. What would the rate equation look like? Similarly, what if I had a reaction that had O3 reacting with chlorine, and let's say that was first, that's first, and that's the final one. Let's say we had CbR4 plus OH minus, and we'll say that that's first and that's 0. Okay, pause the video, try and write the rate equation to then come back when you're ready. Okay, so in each case, our rate equation would always start rate equals K. Because it's always the rate of reaction equals the rate constant multiplied by the concentration. In this case, the NO2 is going in and it's second order, so I'll raise it to the power 2, multiply it by O2, which is first order, so it stays like that. On the second one, O3 and CO2 are both first orders, so they'll both appear in the rate equation and be raised to the power 1, which effectively looks like it's not appearing at all. My final one, I've got CbR4 raised to the power 1, and my OH minus is a 0 order, so that doesn't appear in my rate equation at all. So I hope you found that straightforward. In my next video, we'll look at how to calculate the value of the rate constant. I'll see you then.